Okay, now we want to look at how we can graph these polynomial functions which do not factor under ordinary means. I hope you have reviewed some of the options behind synthetic and long division because we're going to implement some of them with these problems. First off, what we do know is that we have an x cubed in each one of these, okay? And it's a positive x cubed. So we should be of the persuasion that our graphs are going to generally look something of this sort. That's the end behavior exhibited by x cubed with the leadoff coefficient positive, okay? Now, absolutely you're going to try to factor these by splitting combinations, whatever you can. But I'll tell you ahead of time, they won't happen. So that's why we picked them. We're going to introduce you to the new topic, okay? What these slideshows had suggested was that this as the x-intercept is very much a giveaway for what your possible this as a y-intercept, I should say, is very much a giveaway for what your x-intercept is going to be. So the x is going to be any value of a, which is a factor of 8. Okay, so that would be 1, 2, 4, or 8, and all of those could either be plus or minus. So we have all those as possibilities. Now, what we know is that if the value of x equaling a is an intercept, then it should be obvious that the function evaluated at a should give you 0. Now, so you want to kind of get a feel for what are going to be your start off values to plug in there. So you might say, well, gee, I don't want to put in these larger values, and you shouldn't. You should start with the smaller ones. And also, we should probably agree that you can't put in any positive values because all you're doing is adding numbers with no negatives. Because if you put in a value, a positive value for x, none of these will be negative, so this thing will never go to 0. Now, you can try it if you want, but there's one look at that should be kind of a giveaway. So we're going to start low. We're going to say, well, let's try -1. So if -1 goes in, I get -1 cubed, which is -1. I get -1 squared, which is 1 times 6, which is plus 6. Okay, -1 times 12 is -12, and then plus 8. Okay. Well, unfortunately, the positives yield 14, the negatives yield 13, so they don't go to 0. So I'm going to have to step it up. We'll go to f equals, we're going to try evaluating at -2. So evaluating at -2 cubed is -8. -2 squared is 4 times 6 is 24. -2 times 12 is -24, and then we have an 8, so it looks like we got something here. We got the -8 and the positive 8 canceling out, so this is working for us. So therefore, the x value equaling -2 is an intercept. Mainly because the function evaluated at -2 yields 0. So then if x equaling -2 is an intercept, x minus a -2 should equal 0, which implies x minus a -2, or should we say better off, x plus 2 is a factor. Okay, so now that we got a factor, our long division will allow us to find another factor. So here we go with the long division. X plus 2 is the factor that we want to divide into our original polynomial of x cubed plus 6x squared plus 12x plus 8. Okay? And the long division, x in the x cubed goes x squared times x squared times x squared times x, the x out front here is x cubed. X squared times 2 is 2x squared. Okay, we draw the line and we subtract. Okay, Subtracting, the x cubes disappear. 6x squared minus 2x squared is 4x squared. Bring down the next term, which is 12x. Do the division again. X into x into x, 4x squared goes positive 4x times. Okay, 4x times x squared is 4x squared. 4x times 2 is 8x. Subtracting, we go 4x squares cancel out. Subtract 12x minus 8x is, of course, 4x. Bring down the next term, plus 8. Do the division again. X into 4x goes 4 times. 4 times x is 4x. 4 times 2 is 8. And of course, what's nice here is that, pull this down, nice. When we subtract, we get 0. So effectively, this expression, which we had, has now been factored. So the expression that we had of, I'm going to put it over here so we can see the whole thing, okay? And we'll do this on the next video. So the expression of x cubed plus 6x squared plus 12x plus 8 has been factored into the factor x plus 2 and x squared plus 4x plus 4. But then that is a quadratic which factors again as x plus 2 and x plus 2 with this factor of x plus 2. So basically this graph is x plus 2, the quantity cubed, and which is a pretty straightforward graph because the graph is simply a translation of the x cubed graph 2 units to the left. And of course we do know that the y-intercept is up here at 8. So we're getting our typical x cubed graph looking like that, intercepting at -2 on the x-axis and at +8, and there's our graph. Okay, so we'll look at the example 2 in the next video. So we're going to try to stop this at this point. Okay, and